everyone. A ship A is sailing due south at 8 miles per hour, and ship B, which is 16 miles south of A, is sailing due east at 6 miles per hour. We're going to answer these questions. At what rate are they approaching or separating at the end of 1 hour, and also at the end of 2 hours? And also, when do they cease to approach each other, and how far are they at this time? All right, so let's just set up the whole problem. Let's draw a little picture. Let's let A and B be the initial positions of this ship. So these are your initial positions, A and B, and A sub T and B sub T is going to be their positions T hours later. So basically, this is your B coming down. A is going due south. So this is your A axis, and this is going to be your B. So going down south, this is down south this way, going that way. And then your B is going this way. All right. This is your B of T after T times. This one is your A sub T going down this way. All right. Now, our distance is somewhere in between here and here. I'll just do it. We don't really know right now. So we're going to find that. But we can set up the equation for 16. We have 16 miles south of A, starting at 18. So since it's south, this is going to be 16. I'll write it here. Minus 8t for your A value. And for your B value, this one's just going to be 6t, because that's going 6 miles per hour. So it's going to the right. Since this is going down, you're subtracting like that. All right, so that's a bit of the setup. So we're going to find the distance being the distance between T hours later. So that would be this line right here. So we're going to have distance squared equals 16 minus 8t squared plus 6t squared. For that, let's go ahead and differentiate with respect to t, rd squared. And this is going to give you the derivative with respect to t of this side. So this would be 16 minus 8t squared plus 6t squared. All right. So for this piece, you're going to get 2d times the derivative of d with respect to t. And for your t, this is going to be 2 times 16 minus 8t times the derivative of your inner function, which is negative 8. And then for this piece, we're going to get plus 2 times 6t times 6. And this one would be times the derivative of t with respect to t, but we don't need to put that there. All right. So basically, let's simplify this. When I move on, I can divide everything by 2. We have this piece, and divide each term by 2. So this is going to give us d times derivative of d with respect to t is 16 minus 8t times negative 8 plus 6t times 6. Okay, this is going to give you negative 128 plus 64t plus 36t. All right. That means, what are we going to get? This is going to equal 100t, and then minus 128. All right, so that's what this equals. Therefore, our derivative of t with respect to t equals 100t minus 128, and I'm dividing by that d. All right, so this is what we need to answer our questions. So let's see if I can squeeze it in on this one. It says, at what rate are they approaching or separating at the end of 1 hour? So what you'll do is look at when t equals 1, we're going to have d squared equals 16 minus 8 squared plus 6 squared. This is going to give you 64 plus 36 equals 100. That's d squared. So d equals 10 there. So now let's go back to this and substitute in your d. So now we're going to have a derivative of d with respect to t equals 100 minus 128 divided by 10 equals negative 28 divided by 10. So that is negative 2.8. Now what this means is that they're approaching. So they're approaching at 2.8 miles per hour. Now, when t is 2, you're just going to get d squared equals 12 squared, and that's going to equal d equals 12. So now you do the same thing. We have the derivative of d with respect to t is going to equal 200 minus 128 divided by 12. And to save time, this is just going to equal 6. So that means they're separating. Since it's positive, they're separating at 6 miles per hour. Okay. Now, that was 1 and 2. Oh, we got 1 and 2 done. Now we have to do number 3. So when do they cease to approach each other, and how far apart are they at this time? Okay, so for that, they cease to approach each other when your derivative of d with respect to t equals 0. That means we're going to have t equals 128 divided by 100. And that's going to give you 1.28 hour. That's when they cease to approach each other. All right. Now, how far apart are they at this time? So we go back to our original equation and use our distance formula. And that's going to give you the square root of 16 minus 8 times 1.28 squared. Let me do this squared. Then we have plus 6 times 1.28 squared. This is going to equal square root of 5.76 squared plus 7.68 squared, which equals square root of 92.16. Now this equals 9.6, and that's miles apart. All right, and that would be that answer. Thank you. Have a nice day. Bye-bye.